Hello, and welcome to The Shrinking World, 5 things everyone needs to know about micromolding. My name is Aaron Johnson. I'm the Vice President of Marketing and Customer Strategy here at Accumold. Thanks for joining us here today. You know, it might seem cliche, but the world is still getting smaller. And one of the challenges we find our customers facing is the idea of doing more in the same space or more in less. This whole miniaturization challenge has put a lot of pressure on the supply chain, and many of our customers are trying to overstuff the suitcase, if you will. Trying to do more complex things in smaller spaces has become a real challenge. But today I want to talk about one of those enabling technologies, micro-injection molding, that has helped customers around the world do more in the same space or more in less. Those 5 things that I want everyone to know today are: what is micromolding, just the basic definition of what it is, some guidelines around how to design for micromolding and material selection. Those things are very key. The third thing I want everyone to understand about micromolding is the prototyping challenges and how to get accomplished what you need to get accomplished from an R&D and prototyping standpoint. Fourth is the quality assurance and delivery, and understanding that it's not just one, but it's many, it's millions perhaps, and understanding how to produce and get the quantities and the quality that you need at the end of the day. And the 5th thing I want everyone to know about micromolding is really answering that question. I didn't know you could do that with plastic. And just to show a few examples of some of the things that we've done to help our customers around the globe solve their miniaturization challenges. So to get started, then what exactly is micromolding? There really isn't a textbook definition that says this is exactly what it is. But over the years, we've kind of come to define micromolding in one of 3 ways. Certainly micro in size is one of the key attributes, very small, tiny precision components. But it could also be micro features on maybe slightly larger plastic, microfluidics or other tiny features that make this part more complex than maybe a standard injection molded part. And the 3rd way we've come to define micromolding is micro-intolerance. Some of the projects we've worked on have plus or minus 2 or 3 microns in positional tolerances, so they can be very extreme in a lot of cases. So it can be micro in size, micro in features, or micro-intolerances. And in a lot of cases, it's all 3. We usually find the compelling reason that your current supply chain is saying no, it's too small, or it's too difficult, or the tolerances are too tight. There's usually something that gets a micromolder involved into the equation. So that might lead to then, well, what are the guidelines? What's the difference between standard injection molding and micro injection molding? Well, in a general sense, it's still injection molding. You still need a way to open and close the mold, you still need a gate, you still need a way to eject the part. Even draft is welcome on some of these micro parts. So those rules do apply, but it really comes down to where can you push the limits? How small can the gate be? How thin can you mold? What kind of materials can you process? So usually, there's a lot of questions that go around that, and there's a profound relationship between all of those things. So what we really recommend is start with your ideal. Start with that napkin sketch idea that says, maybe might be a little extreme, but let's take a look at it, because you just never know whether or not the project could be successful or not. So we highly encourage you to get in front of your micromolder and talk about the project through the Design for Micromolding process, the DfMM process that we kind of call it. And you sit down and you go through what's critical and the complexities of the project. And again, you just never know what might be possible. So to kind of illustrate that, I want to take a look at kind of one case study that we did that really demonstrates maybe the difficulty in the design side of things that you might run into when you're designing for micromolding. And that's material selection. Oftentimes you pick material selection for the material properties itself, the heat deflection, its stiffness, whatever, the myriads of properties that resins offer us. And then you go from there and you try to design the part and you try to decide, well, will this material work in this situation and all the above? And then you get down to the geometry and the processing of all, and do those things line up? And this is where we did a study to kind of show that relationship and that demonstrates how difficult that conversation can be. We did this thin wall study where we kind of designed this very thin high aspect ratio component with the optimal thick to thin transition to just kind of give it its best chance. And we tried to put ourselves in the design engineer's shoes and say, well, okay, what would it take in order to make this product? And asked all of our resin suppliers, which resin do you recommend in order to mold this part with this thin wall high aspect ratio? And what we found was that every one of our resin suppliers said none. They didn't think they had any material that would fill this part out as designed. Some suggested molding it thicker, grinding it down, stepping it down. They gave a variety of suggestions. But a response like that could hinder the project or stall it altogether because maybe the design is actually critical to the function of what you're trying to put together. So you kind of hit a wall and then put your hands up and say, well, I guess I can't make this product. Well, that isn't necessarily the case, and why, again, the importance of talking to your micromolder is key in situations like this. So we knew that all 11 of these common resins wouldn't run the full 42:1 aspect ratio, but we knew some had a good chance and some would had a variety of responses in between. And so we kind of put this study together to show that relationship. So here on this slide you can see that 4 of the 11 resins ran the full 42:1 aspect ratio, and then a variety of responses in between, all the way down to peak there at the bottom. And that's not to say 3:1 is the max aspect ratio for peak, that's just how it performed in this particular case. But here you can see how material selection, it can have an extremely different outcome depending on which one you choose and the geometries that you're trying to put together. And this is really where the experience comes in. There really isn't a data sheet or a textbook that tells you exactly how to put these all together. And you need to find your trusted partner, your micromolder, that has the experience in order to help you and guide you through this process. The third thing I want everyone to know about micromolding is the prototyping challenge. Most cases you're not just trying to make one thing. Perhaps you're trying to find if your one thing works, but ultimately usually there's a goal after that. You need to make hundreds, tens of thousands, even millions a month perhaps. And it's all dependent upon whether or not you can get this process to a robust place. And that usually starts with, let's build some prototypes. Up until recently, there haven't been too many rapid prototyping processes that could get you the full distance. We designed this kind of standard part, again, another case study to just show how difficult it can be sometimes to get the projects done that you need to get done. So we designed this part with all sorts of fine details and tiny features to just kind of demonstrate the complexity of some of the projects that we might see. And so we sent this model out to just about every prototyping house that we could think of and asked every different process, can you make this part? And many of them no-quoted it and said, no, the part's too small, the details are too small. Fortunately, over the years, a lot of new technology has come online and has really helped advance microprinting and the rapid prototyping process. A couple of those of note are DLP printing and 2-photon laser printing, which I'll highlight here on the next slide. But the whole point is how can you get a production-like or some kind of prototype that helps you along the way without building a hard steel tool and going through all the time and expense that would require. So here you can see a variety of responses, everything from the SLA to a machined part, to the DLP printing and the 2-photon laser printing. And then on the far right, you can see the molded part and how they kind of compare. Again, a wide variety of responses. Each one has their pluses and minuses. The 2-photon laser and the DLP have extremely high detail capabilities these days. The DLP printer that we have has 1 micron layer capabilities. That wasn't possible all that long ago. So again, great advancements in this. But then again, they're still printed parts, so they may not completely function with the thermoplastic that you're after, but it might get you further down the road in terms of form and fit and other functionality pieces that you might be looking at. So there are a lot of advancements when it comes to rapid prototyping, but it still might not be what you need, and it still might come down to having to cut hard steel and to make an actual mold. Again, positives to that is you get an actual part that's production-like and in the resin that you need for your project, but it can be costly and time-consuming depending upon the nature of the part and the complexities that go all into that. So it's another one of those conversations you want to have early on in the process, especially if you're going to cut hard steel for prototyping, so that you know maybe what needs to change or iterate through the process so that can be built into the tooling, or perhaps there's some 3D printed pieces that could get you a little bit farther along the way, and just to find a good process to get you what you need when you need it with the efficiencies that you're looking for. The fourth thing I want everyone to know about micromolding really comes down to quality, metrology, delivery, kind of what seems sometimes to be as an afterthought. Oh, we've got this complex part. Can we get it made? Oh, we got it made. All right, now what do we do with it? We spend a lot of time up front understanding what does the end goal look like, especially when we're heading towards a production tool, and understanding, okay, what are the quality requirements? What are the critical dimensions? How are you going to measure them? What kind of packaging is going to be needed in order to get them to your contract manufacturer, your own manufacturing place safely and protected? These are all questions that need to be known up front so there's not any surprises. We talk often about the total cost of quality. Sometimes we're just focused on, well, what is that piece part price? And we forget that there's a whole lot that goes into that. At the end of the day, what does getting that part to your manufacturing site mean for you in terms of value and functionality and speed to market and all the intangibles that go into that? We try to build those things up front in understanding so that at the end of the day, you get a smooth process and that you have the product and the volume that you need. One of the things that we point out the most is make sure when you're having your conversation with a micromolder is understand their capability. Certainly, can they make the part that you're after? But understand their scalability. Can they get to where you need to go ultimately? Can they make the millions a month? Do they have the infrastructure and the systems and processes in place and even the certifications in order to give you confidence that yes, this is going to be a partner that's going to be with you for a long time? We call that sustainability. It's the partner that is not only here today, but throughout the entire life cycle of your product. In consumer electronics, maybe that's 18 months. But in medical or automotive, that could be 10 years. So understanding that scale and starting that project with a micromolder up front is definitely a key thing that I want you to understand when you're embarking on a micro project that involves micromolding. And that whole handling and packaging piece of it comes in, do they have systems or do you need automation? Is there some assembly or some kind of automated insert that needs to go into the process so that you have a very robust, very efficient process, so at the end of the day, you get what you need, how you need it, and where you need it. Very important thing to understand. So the fifth thing I want you to know about micromolding is really just the show and tell part of the conversation. Just to highlight a few things that we've done over the years to maybe get the wheels turning about something that you're trying to solve right now. This particular part is one of the smallest commercial parts that we're allowed to show. It's only 800 microns at its longest feature. The discussion around how it was going to be gated, ejected, handling the part was actually harder than the molding side of it. Again, all conversations that needed to be had up front so that at the end of the day, the project was successful. This particular part really demonstrates one of the key aspects that we talk about when it comes to miniaturization, and that's part consolidation. Can you overmold? Can you insert mold, put two parts together? Or can perhaps you make the whole thing out of one resin? And in this case, this was traditionally a metal tube with a plastic overmolded hub. And we came up with a way to mold the tube and the hub all in one complete piece of plastic, saving a whole lot of manufacturing process and made for a much simpler component at the end of the day, solving our customer's challenge. This particular component needed two 12-thou pins inserted into the housing in order for the part to function at the end of the day. So we had to handle the pins, get them inserted, and deal with all of the quality requirements that come with that, and then mass produce these at 1 million at a month kind of pace. So it's high precision molding, but at a high velocity, and being able to put those two things together. This is another example of part consolidation and fine media overmolding. This is a fabric mesh. It's part of a microfilter, and we needed to build a system that could articulate fabric through a mold in a multi-cavity situation, if you will, and be able to overmold and singulate and create these components without destroying the integrity of the fabric or the part itself. This last part is one of my favorites to talk about. If you're familiar at all with injection molding, you understand the complexities and the intricacies of a product like this. It's got slides and core pulls coming from just about every direction. It goes from thick to thin to thick to thin again, and it's got 3 discrete inserts all happening at the same time. This is again another beautiful example of part consolidation where we took multiple plastic components, made one very complex part, and put them together. In the end, made a more robust process and made it simpler on other manufacturing processes. But most of all, it actually allowed 2 parts to share the same wall, so it gave them more room on the inside. They needed to add one more electronic component, and that little extra space gave them what they needed. So sometimes part consolidation is the key to miniaturization if you can figure out how to get multiple components together. And this last slide just shows some very complex, high-precision molded components. Not only are they very small and have micro features, they take micromolding to the extreme. These are what we call polymer optics. They have prescription lenses or some kind of light management part of their function. That means that material clarity has to be perfect in processing. That means surface finish has to be optical quality, and then the tolerances have to be spot on. Again, often in plus or minus 2 or 3 microns in a lot of cases. For example, where we're producing 12 250 micron diameter A-spheres on 250 micron centers with a plus or minus 2 micron pitch. Again, extremely small parts with extremely small features, and really pushes the limits when it comes to size and quality and the whole 9 yards, if you will, when it comes to micro injection molding. This last slide just shows a variety of applications where you can take advantage of micro injection molding as you're embarking on your designs and pushing the limits of your own technology and trying to do more in the same space or more and less, and might find yourself kind of in a jam and looking for a solution out there that is robust and allows you to get to commercialization as fast as you can. But at the end of the day, we have really just one rule. So if there's one takeaway of the 5 things, we want you to start with your ideal in mind. Bring us those napkin sketches. Have those conversations early in the game so you can head down a path that gives you the most chance for success and avoid time and cost in the process. We often hear from our customers, we're not quite ready, the design isn't done. And we usually say, no, time out. That's exactly when you need us to be involved, to look at projects to see what is possible, what may be possible, what isn't possible. To have those conversations early on in the conversation really is better off in the long run. So bring those napkin sketches and those wild ideas, and you just never know what might be possible. Again, I want to thank you for joining me today. Just very briefly about Accumold, our company. We've been around since about 1985, solely focused on micro injection molding. It's what we do. We serve our customers from Iowa, little Ankeny, Iowa, here in the middle of the United States, and we serve customers all over the world. We'd love to hear about your project. So if there's something that you'd like us to take a look at or questions you have, please don't hesitate. You can go to our website. There you can click on the Contact Us link and fill out a form, and we'd be glad to get back to you and discuss your project. And you just never know where your innovation might lead you. Thanks again for joining us today.